So, hey everybody, today we are going to see this unit 6 of modular and structured design. So, as you know, we will straight jump to the introduction. In this unit, you will learn the process of designing systems internals. We will begin at an abstract level, taking systems processes in the form of data flow diagrams and convert them to structure charts. Structure charts represent design graphically. You will learn the process of drawing structure charts and how to derive them from data flow diagrams. The structure charts you create will form the basis for the structure of the system you design and build. Decisions made at this point will influence the overall design and implementation of the information system. So, you need to be aware of what constitutes a good design. You will learn about some guidelines that will help you achieve it. The primary goal behind good design is to make your system easy to read and easy to maintain. The primary way to do this is to divide the problem solutions into smaller and smaller pieces or modules. The smaller the pieces of modules, the easier it is to program, to read, and to revise due to changing users' requirements. Modularization therefore promotes ease of coding and maintenance. On the other hand, modularization is not simply reduction of size, but it is also a reflection of function. That is what particular piece of a system, that is a module, supposed to do. One guideline for good design is to maximize cohesion, to extent to which a part of the system is designed to perform one and only one function or task. Modules that perform single tasks are easier to write and maintain than those performing different tasks, as modularization also involves how different parts of the system work in conjunction with each other. Another guideline for good design is to minimize coupling, the extent to which different parts of the system are dependent on each other. Objectives: after going through this unit, you should be able to know the meaning of design, learn the process of top down design and bottom up design, learn the process of drawing a structure chart, learn the goals of design, differentiate between five types of coupling and apply them in programs, and differentiate between seven types of cohesion and apply them in programs. Design bridges the gap between specifications and coding. The design of the system is correct if the system is built according to the design that satisfies the requirement of the system. Verifiability: it is concerned with how easily the correctness of design can be argued. Traceability: it helps in design verification. It requires that all design must be traceable to the requirements. Completeness: the software must be complete in all respects. Consistency: it requires that there are no inherent inconsistencies within the system. Efficiency: it is concerned with proper usage of resources by the system. Simplicity: it is related to simple design so that user can easily understand and use it. Simple designs are easy to maintain in the long run or through the life cycle of a software system. Design principles: there are certain principles that can be used for the development of the system. These principles are meant to effectively handle the complexity of process of design. These principles are problem partitioning. It is concerned with partitioning the large problems. Divide and conquer is the policy adopted here. The system is divided into modules that are self-dependent. It improves the efficiency of the system. It is necessary that all modules have interaction between them. Abstraction: it is an indispensable part of design process and is essential for problem partitioning. Abstraction is a tool that permits the designer to consider a component at an abstract level, outer view, without worrying about details of implementation of the component. Abstraction is necessary when the problem is divided into smaller parts so that one can proceed with one design process effectively and efficiently. Abstraction can be functional or data abstraction. In functional abstraction, we specify the module by the function it performs. In data abstraction, data is hidden behind functions/operations. Data abstraction forms the basis for object oriented design. Design principles are necessary for efficient software design. Top down and bottom up strategies help implement these principles and achieve the objectives. A system consists of components called modules, which have subordinate modules. A system is a hierarchy of components, and the highest level module, called superordinate module, corresponds to the total system. To design such a hierarchy, there are two approaches, namely top down and bottom up approaches. The top down approach starts from the highest level module of the hierarchy and proceeds through to lower level. On the contrary, bottom up approach starts with lower level modules and proceeds through high levels to the top level module. Top down design. This approach starts by identifying major components of the system, decomposing them into their own subordinate level components, and interacting until the desired level of detail is achieved. Top down design methods often result in some form of stepwise refinement, starting from an abstract design. In each step, the design is refined to a more concrete level until we reach a level where no more refinement is required and the design can be implemented directly. This approach is explained by taking an example of library information system depicted in figures 6.1 and 6.2 and 6.3. So here you can see the figures, the top root of software system, and here 6.2 further decomposition of the top of software system, and divide the system even further 6.3. So here you can see the diagram. Okay, now we will see this iterative process can go on till we have reached a complete software system. A complete software system is a system that has been coded completely using any front end tool, X Java, Visual Basic, V, C++, Power Builder, etc. Top down design strategies work very well for a system that is made from the scratch. We can always start from the main menu and proceed down the hierarchy, designing data entry modules, queries, modules, etc. Bottom up design. In bottom up design, we start from the bottom and move upwards towards the top of the software. This approach leads to a style up design where we decide the process of combining modules to provide larger ones, to combine these to provide even larger ones, and so on till we arrive at one big module, that is the whole of the desired program. This method has one weakness: we need to use a lot of intuition to decide the functionality that is to be provided by the module. If a system is to be built from existing system, this approach is more suitable as it starts from one existing modules. And here we come to the first check your progress, and till here we will end, and the answers of check your progress you can check in the description, okay, which will be provided soon. Okay, Next lecture we will start from 6.3. Okay, till then keep exploring.